This is Miss Getz again for Algebra 2B. We're going to do Unit 1, Lesson 4. In your packet, it'll be 8.5. We're going to talk about exponential and log equations. Basically, we're going to be using algebra to solve these. We're going to solve for x. So I'm just going to do examples because I think that's the easiest way to approach this. So if I say solve 7 to the 3x equals 20, you've never really had a problem like this because we cannot do anything with this if it's in the exponential form. That's why we have logarithms, because we get to use logs. So if you see your x as an exponent, you're going to always take the log of both sides. Okay? Now, the rule of logs tells me that if I have an exponent, I get to bring it out front. That's why we did those properties of logs. So I get to bring this 3x out front. Because now I've turned it into a log, I get to use those properties. That's the point of it. Now, my goal is to get this x by itself. So I know I've got to get rid of 3, and I've got to get rid of log 7. Log 7 goes together. You can't separate those. I'm going to get rid of log 7 first. And since they're all being multiplied, I get to divide. So these cancel out. I'm left with 3x. Now, this in my calculator would be like this. I'd have log 20 divided by log 7. And that's going to give me 1.54. Now, how am I going to get x by itself? Divide by 3. Since it's already in my calculator, I can just say divided by 3, and it gives me 0.513. So, if I were to replace this with 0.513, it would give me 20 when I worked it out. Okay, let's do another example. If I want to solve 6 to the 2x equals 1500, this is just like the problem before. I could have brought this out. I could take the log of both sides and bring this out front and that kind of thing. However, I can also do another thing. I can also graph each side. I can make this y1 and this y2. So if I go into y equals and clear it out, I can say y1 is 6 to the parenthesis 2x, and then y2 is 1500. But I got to make sure my windows go clear up to 1500. Whoops. And graph. Now, if I go second trace, intersection, wherever the wherever these intersect, that is my solution. So if I go second trace 5 and enter, that means wherever these two intersect, and you can do any equation like this, not just exponential functions. I could take 2x equals 4 and graph those, and wherever they intersect, that's my solution. So if I look at my calculator, I know you guys can't see it very well. This says 2.04. So my solution is 2.04. I didn't have to go through the algebra. Now, if you'd prefer to go through the algebra, this problem looked exactly like the problem we did before. All right, let's do another example. Solve 2 times 1.5 to the x equals 6. First of all, I can't say take the log of both sides if I have something hanging out here. Notice before I got to take the log of both sides because all I had was a base and an exponent. I have to just have a base and an exponent. So the first thing I do is I get rid of this 2. I can divide it. Now I have a base and an exponent. I get to take the log of both sides. Now, what did I say to do with this exponent? The properties of logs tells me I can bring it out front. So x of log base 10 we don't put, of 1.5 equals log of 3. We don't even have to say base 10. Now, how do I get x by itself? Well, these are being multiplied, so I divide. Cancel. I put these in my calculator. Remember, there's parentheses around both of these. And when I do that, I should get 2.71. Now, if you're having trouble with your calculator when you get in class, I can sit and help you. But the only difference in these problems is you see the word log, and you have to follow those properties. But everything else is traditional algebra steps. Okay, next. Let's do... There we go. That's a little more clear. If I ask you to solve log of 3x plus 1 equals 5. Okay, if we're in log form and we want to solve, we have to write this in exponential form. So, here's what I want you to remember. When we did notes earlier, and I showed you this, we went from log to exponential. So we're going to use that. So I'm going to write that on my paper. I'm going to write it over here. I'm going to say y equals b to the x can be written as log base b of y equals x. Just so that we can reference that. We're in this form right now, and we want to go to this form. So what I know is my base, if there's no base, is 10. So I'm going to write it in. My y is going to be 3x plus 1. So I'm going to write 3x plus 1 equals. My base is 10, and my x is 5. All I did was follow and fill in. Now, you can put this in your calculator. 10 to the 5th is going to be 100,000 minus 1 is 99,999 divided by 3 is 33,333. Sorry. Once I get rid of the logs, this is an easy Algebra 1 problem. But it is converting it from logarithmic form to exponential form. And if you're having trouble, I suggest that this sits there beside every problem. So let me repeat myself. When there's no base, you till base 10. This represents, if I look down here, this represents y, this represents x. If I look log base y equals x, log base y equals x. My base is 10, my y is this, my x is this. If I want to write an exponential form, I write y first, my base to the x power, which is 5, and then I solve. All right, one more example. Let's solve 2 log x minus log 3 equals 2. First of all, if you're going to solve these, you have to put it in a single log. You're going to use those properties of logs. That's the first thing you're going to do. So what I know is I know that I can bring this and put it as an exponent. So log of x squared minus log of 3 equals 2. I know I can do that. I also know when there's subtraction and they're the same base, which is 10, then I get to divide and put it in a single log. So log x squared divided by 3 equals 2. Then I cannot solve a problem with logs like this. I have to put it in exponential form. So again, I'm going to bring back this y equals b to the x. I can write it as log b, base b y equals x. So here I have log base 10 of y, this is y, equals x. So my y comes first, equals my base, which is 10 to the second power. Now this is just regular old algebra. I have x squared over 3, x squared over 3 equals 100 if I put in my calculator. I'm going to multiply both sides by 3. How do I get rid of a square? Sorry. I square root both sides, and it ends up plus and minus. So I have x is plus or minus 17.32. So there are two possible answers that would work up here. Whenever you square root both sides, you remember this is plus or minus. For lesson 4, you are going to do worksheet 8.5 in your packet. When you get into class, I will tell you what those assignments are.